So welcome back everyone. We are going to have our very first lesson on projectile motion. Yes, a very serious concept in mechanics. And this is what really people wanted us to reach. And here we are going to cover the first quarter of projectile motion. Then our next lesson, I think we shall see how we can play with the other quarters. So of course, we are going to have the course outline so that people know what we are really going to cover today and what will come later on. So allow me begin with the course outline. So the course outline one, supposed to define projectile motion. Need to know what projectile motion is. Then supposed to resolve the terms used in projectile motion. And after that, the third thing, we look at the three cases. Yes, we look at the three cases. So you may be asking, what are those cases? The first case is an object. The first case is an object projected. One, it can be horizontally. The object can be projected horizontally from a height above the ground. Of course, it cannot be projected at the level of the ground from a point or from a height. So from a point above the ground, that is case one. Then there is also a case where yes, we can have the body being projected from the ground, but of course it's going up but at an angle. So we have an object projected upwards, but this time around from the ground. So if it is upwards, it is okay to be from the ground, upwards from the ground at an angle. And you all know in most of the cases, these angles are with the horizontal, with an angle to the horizontal. You all know, I told you this when we were resolving forces, the very first topic in mechanics, that most of the angles are to the horizontal. We start counting them from the horizontal. Then the other last case, it is still upwards, but from a certain height from the ground. You get? And that one usually disturbs a lot of people, but we are going to look at all those cases. So there is projecting the body still upwards, but this time round it's from a certain height or from a point above the ground. but still at an angle. Yeah, it is upwards from a point above the ground. I told you the point can be called the height. From the point or height above the ground, but still at an angle to the horizontal. So this one will be part. So what are we really handling today? So of course, the very last things, those will be enough. Last things, and four shall see standard equations. I will hint about standard equations. Yeah, standard equations of projectile motion. I don't know if Ben is on because Ben gave me a misconception on the word projectile and I want him to learn it today. I don't know if he's on. So that is 4 concerning the standard equations. Then 5, of course, it is research and assignment. That is the general course outline. And trust me, if we are done with that, research and assignments, that will be the end. Of course, those cases have examples with them. We just don't look at what they mean. Yeah, so we shall look at those cases and associated calculations. Yeah, we look at those cases and associated calculations. Now, for today, I want us to, this is a lesson target. Resolving terms used is also our lesson target. So concerning the cases, this is our only lesson target. Yeah. So concerning these two, that will be next time. Yeah. So the next time we are here, we shall only be talking about upwards. We shall only be talking upwards, and that upwards will be at an angle to the horizontal. And the only difference shall be that this is from the ground, but the other one will be from a point above the ground. So they will be kinda connected. That's why I prefer them to be in the same session. But I want the introduction and everything, and also some calculations involving the horizontal one to be so specific and on their own. That's what we are covering today. So we are going to define, resolve terms, handle case 1, and then we leave other cases for next time. So for today, we are handling case 1. Yes. Yeah, the other ones are other cases. This one is case 2, then case 3. Case 2. I think that is enough introduction. So we need to know, what is this projectile motion all about? You've been hearing a lot of words. People have been overscaring me concerning the topic and so on, but we have not been hearing that. So one thing you need to appreciate is that we have just looked at vertical motion under gravity recently. So one thing you're not supposed to forget, that still projectile motion is under the influence of gravity. That's what people first forget. But projectile motion is also still under what? The influence of gravity. That is the very first thing you're not supposed to forget. By this kind of motion, you may think we have left the things we've just covered so far, but they are still part of us. So first appreciate the fact that the projectile motion is still under the influence under gravity. Then other things will become very easy. All the disturbing concepts and parts concerning projectile motion arise as a result of people forgetting the fact that we are still talking about gravity. or after people forgetting that actually projectile motion respects gravity. So, how can we define projectile motion? Or before even define what is to project? Yes, what is to project and what is a projectile? So, if at all this is a person, if at all we have our person here, have my person in a funny way, like that. This person has hands, whatever. So if this person is holding something, let's say a ball, can have our person. This person can have a ball still. So this person can decide to throw the ball like that. That is throwing. This person can decide to throw the ball like that. I don't know if people see this. Are you seeing that? This is all throwing. I think you can see how those people are placing their hands. Someone can decide to throw the ball like that. So what this person is doing is projecting the ball upwards. So this is what I can call upward projection. I think you can see that. So for that first case, our person is projecting the ball upwards. That's why they usually tell us that it may occur at an angle, but that angle is always with the what? With the horizontal. So this may be the angle people always talk about, but this is for the next lesson. But I just wanted to show you what projecting something upwardly means. That is it. So in case this is our next person, this has been our case. This has been case A. So this is our case B. So what if the person decides to throw it like that? I think you can see it is totally horizontally. The boy is just giving it a horizontal push, but here we pushed it up. Here the boy is giving it the horizontal push, and this is what we call horizontal projection. I want you to follow. The moment I leave you, you're gone. Because now we are still just jazzing. Horizontal projection like that. So what I want you to appreciate is one, that as you're throwing this ball, you give it a certain initial velocity. That one you must appreciate. As you're pushing that, you're the one pushing it. You're either pushing it horizontally or you're pushing it vertically. Every time you give it a push, you give it an initial velocity. That is something you're not supposed to take for granted. And I'll put it as a note because it is a basic concept. Note. Every time the ball is given a push, it's given an initial velocity. It's given an initial velocity with which it moves. You need to understand that. So when this boy pushes it up with any velocity, it first moves with that. when the boy pushes it horizontally, it's given that initial velocity with which it moves. And you all know that every time we mention initial in math too, or in mechanics, we mean our small letter u. Understand that. Now, we have agreed that this case A for upward projection, it is later. But this one is the one for today. So we are going to concentrate on this. Now we are going to begin the explanation. Yeah, before you can even go to the terms involved. The terms involved are not hard. You're not going to find that time with them. But horizontal projection, that's where my emphasis is. Yeah, so let's first do that. So I'm going to sketch again. So another thing you must understand, or what I believe you know, you people, when that ball is given the horizontal push, do you think it eventually falls or it doesn't? Or it just keeps like that? Does it fall or it doesn't? If it's given that, does it eventually fall? Let me see what people are saying in the chat. That is good. So we are saying that the ball eventually falls. So I need to know what makes it fall. The ball eventually falls. So what people mean that this will later happen. It eventually falls. Which you're right. But the question is why? Who can tell us? Exactly. Someone is saying it doesn't. Some of you are not easy. So this is the point. The moment you push this ball at this instant, the moment you push it, immediately gravity starts pulling it down, pulling it down, pulling it down, pulling it down until it gives up and it finally starts falling up to when maybe it reaches the ground. I don't know. Anyhow, but that's what I meant. The moment you start, so this is your gravity, and people have the idea. So for you, the moment you project it horizontally like this, immediately you start doing so. Gravity starts pulling it down, pulling it down, pulling it down, pulling it down, until it eventually falls down to the ground. You like it or not. So it never keeps the horizontal path. That's one thing you're supposed to understand. And it is important, and it's going to cost you. So because of that, we note this. So that's what you must know, that the ball eventually falls. Why? Because of the gravity. So this is something else you're supposed to note, that this ball goes like this, and then we are saying that it eventually does what? Falls. That means that the ball has two kinds of motion. I want you to follow. And get these concepts well. Don't cram anything. The ball has, or faces, whatever, two kinds of motion. Faces, or has, or undergoes two kinds of motion. you need to know that it is pushed. But immediately after it's pushed, gravity starts straight away trying to pull it down, pulling it down, pulling it down until it's successful. You get the point? So that ball has what we call horizontal motion. And what causes that horizontal motion? It's the push it was given. So this motion we have said, it is because of the push it was given. Simple as that. Then the other motion the body undergoes, faces, or it's having is the vertical motion. And what causes this vertical motion? The gravity. So that vertical motion is because of the gravity that acts immediately. After the push. You need to understand those two. I want you to follow slowly. So it has two kinds of motion. It has the vertical one, and it's also having the horizontal one. What causes the horizontal one? The push you give it. What causes the vertical motion? The gravity that starts acting immediately after the push, and it's finally successful by taking our body up to the what? Up to the ground, as we have explained. Now, I may write the heading officially, and our heading is an object projected horizontally, and it's supposed to be from a point. I told you that we cannot have the ground. I don't know whether people got me. We cannot have this as the ground and then our body is just here. And then we say we are going to just push it like this. This is something else. That cannot be projection. Like there is nothing you've done. We shall not even have any form of vertical motion because the body is on the ground, so there is nothing like falling. So this is not valid. What is valid is having something here, and you're saying that this is your ground, and the body is somewhere here, and the body is given that horizontal force, but we know it eventually must what? Must fall. So this is the perfect one. So today we are going to handle the first case, that is case 1. Then the other lessons shall be for case 2 and so on. So what is case 1 saying? Case 1 is for an object. Okay, that has been an introduction. Concerning projectile motion. I'm going to talk about a few definitions which you already know. And I'm sure you know. Now, I want to ask people, what is a projectile? You people, what is a projectile? Or what is the projectile? Or what is a projectile? I don't know if people know what this means. Who can tell me what is a projectile? Let's resolve a few terms, then we derive equations for horizontal projection. We write everything. Who can tell us what is the projectile? In normal mathematics words, what is a projectile? If they tell you projectile, what do you understand? Or do you know any examples of projectiles? Or you people don't know? Why are people quiet? Let me see what people have in the chat. the motion of a body from its rest, projecting a body here. You people are just forging things. Okay, let me give you two options so that people choose. I'm having here, having a stone, being thrown, and then here I have the path, followed by the thrown stone. So let's assume the stone we are throwing is option A, and the path that stone we have thrown is following is option B. Of the two, which one is the projectile? Because I've just realized people don't know these things. And I'm disappointed. Which one is the projectile? Eh? And I know it is BCM students answering. eh, 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 eh. You people, let me teach you. For me, I thought you people know. BCM students are causing commotion. BCM students are causing commotion in the chat with wrong answers. For me, I thought you know. People giving me wrong answers. Hey. That is very bad. That is very bad. You people, a projectile is the object. A projectile is the object. Hey. I'm so disturbed. A projectile is the object. So you people didn't know that when you throw a stone, the stone you're throwing, you didn't know that is the projectile. eh, 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 eh. Let me even write it. A projectile is that object you throw, you kick, you fire, if it's a bullet, you launch into the air, anything. So let's say that a projectile is the object that is thrown. You either throw, maybe it is a stone, you either kick if it's a ball that is kicked, fired if it is a bullet, or you launch it. I don't know what name is given to those things that are sent to the moon. Those are the things that are launched. Yeah, or launched into the air in most of the cases. Into the air. Because all our calculations will always be in space. But have it in mind that these things must be under the influence of gravity. That's the first statement I made. And this moves only under the influence of gravity. Have that in mind. So the projectile from today onwards, learn it from me. It is the object. Which object you either throw, maybe it is a stone, kick, maybe it's a ball, fire, maybe it's a bullet, launch those things they send to the moon. And we are sending these things to air. And we should understand without the influence of gravity, then that's not projectile motion. It's not. I try to show you the two forms. And you saw that the first form of upward, it's totally against what? Gravity. So the influence of gravity must be there, you like it or not. So there are those who may be disturbed by a lot of English in the definition. I can tell you some of the examples. Maybe you can understand. Igi. So when they ask you for the examples of projectiles, you come and say, A stone you throw is an example. A stone you throw. So you people, trust me, if this word is not there, then you're wrong. If you just say a stone, you're wrong. The stone only becomes a projectile if you throw it. You get the point? Because when you throw it, it will move under the influence of what? Of gravity. So it becomes a projectile. When when a ball is just there, it's not a projectile. So when they ask you for examples of projectiles and you say a ball, you're wrong. But when you say a ball kicked into the air, that's the projectile. A ball kicked. That one. Provided they say kicked into the air. Because we now know when you kick into the air, it's going to move under the influence of what? Of gravity. Now it becomes a perfect projectile. But when you just say a ball, you're wrong. A bullet. When the bullet is inside the gun, it's not a projectile. But the moment you fire it from a gun, there it becomes now a projectile. So you can say a bullet. So a bullet alone, it's wrong. But the moment we fire it from a gun, it becomes a projectile. So I will say fired from a what? Fired from a gun. So this one becomes a perfect projectile. You get the point? You people know what we call the arrow and the bow. So someone make for me a statement relating the arrow and the bow. Which one comes from what? And which one is wrong and which is the right statement to make it a full projectile? You know the arrow and the bow. So how can we write that statement? To make it a perfect projectile. Arrow and bow, what can be the statement? Arrow throw from a bow. Yeah. Yes. Yes, need one answer. So an arrow alone is wrong. But when you say the arrow released from a bow, now that one makes it a perfect projectile. So in simple terms, the projectile is a moving object, but not the object. Projectile is the moving object. And we always want it or prefer it to be where? In the air, the moving object. That's why they call it projectile alone. Now that projectile follows a certain path. This projectile follows a path. This projectile follows a path. Who can tell me the name of that path? Called a what? Who can tell me? Who can tell me? Who can tell me the path followed by the projectile? How would we call it? Physics students, please be active. Trajectory. That is it. So hope you people now know the difference between a projectile and the trajectory. So the object that is moving is the stone. So the stone moving is the projectile. Then the path that stone you've thrown is going to follow is what they call the trajectory. Someone may be like, sir, I've not yet gotten you. I've gotten the projectile, but I'm not getting what you're saying about the trajectory. Let me give you an example. Now, assuming you throw a stone. Yes, assuming you throw a stone. Where are we? We are here. We have a lot of options. So, a thrown stone. You can throw a stone and it follows a curved path. Are you listening? You can kick a ball. A kicked ball. A kicked ball. You see that? So when you throw a stone and it follows a curved path, so this curved path is the path. So the thrown stone, kicked ball, you all know this is what they call the projectile. So when you say the stone you have thrown is following a curved path, the curved path is now the what? The trajectory. When we say that the ball we have kicked is following a parabolic path, the parabolic path is now the what? The trajectory. So in simple terms, the projectile is the what? Is the moving object, and the trajectory is now the path followed by the moving object. As simple as that. Don't add on anything else. Hope I've sorted you there. Now, what do they call the angle of projection? That one I explained. That when you're having your body there, I've been using the ball in most cases, and then you give it a push like that. I remember telling you that this push gives it the initial velocity u. I told you that. Then I also added that the angle projection is usually with the horizontal. And I told you it is this theta, and it is usually with the what? The horizontal. Those are the only things you need to understand. And I told you this is now the angle of projection with the rays used. So there are things you're supposed to know about the angle. First and foremost, the angle of projection is to the what? To the horizontal. Then the other thing, as you give the ball this push, you're giving it the initial velocity with which it's going to move. And that initial velocity is what? Is a u. You understand? Hope that is clear. Then the other things, you know them. Most of these definitions, we are going to find them later on. But I think we shall also talk about them. We shall talk about them. Right now, they shouldn't stress us. But I may just hint about them. Maybe when I'm talking about tomorrow's projectile motion, that's when I'll say most of the things. So, I'm going to pose a simple question. So the other terms we are going to look at, that is tomorrow. One is H max, of which you all know that is the greatest height or the maximum height reached. We shall talk about again the time of flight, and you all know time of flight is capital T. Then we shall talk about the range, and you all know the range, it is represented with letter R. We shall see what it means. Then we shall talk about the maximum range as well. So when am I going to cover this? I'm going to try my level best, cover it in session 2, because that's where I need those terms mostly. Session 2. That's why I need to talk about the H maximum, the time of flight, the range and range maximum. If you realize the sketch of horizontal projection may not need me to know the H max. It's like it's the one I have initially. So it's not a point. Where I had to talk about the angle of projection right now, for trajectory, that's among the terms. You just need to be this person who got the difference between projectile and trajectory. Then why I gave you the angle of projection, I wanted to mention this word, that it is the angle with the horizontal, such that I now pose my question. Just that now I pose my question that if at all, if at all, if at all, I'm having my body here, and this is the kind of projection we are having, the horizontal one, like that. And we said that later on it will eventually fall for reasons we said. So this is the point of projection. You all know this is the point of projection. It's where we are beginning the projection from. So my question is, which one is the angle of projection? You tell me in the chat. If at all this is my ball and that's the point of projection and I'm giving it that horizontal what? Push. And we are saying eventually it must what? It must fall. What is the angle of projection in that case? What is the angle of projection in that case? Let me see. Yeah, you people have it right, 0. So as I'm doing these things, I don't want any of you to demand me for the angle of projection because you've said it is 0 at 0 degrees. So don't demand for it. So don't be these kinds of students saying, but doctor, you told us angle of projection, blah, blah, but in whatever you're doing, it's not part. I'm dealing with horizontal projection, and that means we don't have any angle with the horizontal because we are dealing, okay, whatever is happening within the horizontal plane. So it's like we have no angle there. So don't ask for it, please and please. Don't bother asking for that angle, it's not there. Okay, now after all that, I've told you these ones are needed in session 2, and I'll talk about them. Yeah, okay. Now, let's begin with our object. So case 1 for the object. So case 1 we shall say an object. So case 1 it is an object. An object projected horizontally. Projected horizontally from a height above the ground. So now the real work has started. So you either say from a height or point above the ground. So as usual, we are going to have our ground here. I don't know if that line is straight, but I'll try. You forgive me in case it doesn't come out as a straight one. We shall keep trying. I will go with that. No option. So this is our ground, like that, like that, like that, like that, like that. That's our ground. So I can come here and say ground. Very common word. Then even this side, I can have my ball here. I want you to follow. I think you can see that that is our point above the ground. I think you can see the ground and you can see where our ball is. So I think when I say projecting it from a point or height above the ground, you can see that. So we said it is given the horizontal push, this, it is given that horizontal push, but again I said we expect it to later on fall back to the ground like that. We expect it to do what? To fall back to the ground at some point. So I can just have my sketch like that, or whatever, in any way. You can decide to just make it longer, like that. It's the same thing. So that is my sketch. I want you to be getting whatever thing I'm going to be doing, because when I leave you, even at any one point, you're going to be totally and totally lost. Totally and totally lost. Now, I told you that when you push this ball like this, you're going to give it an initial velocity that is going to move with. And I told you that that initial velocity is your u, and you know that u is velocity measured in meters per second. So you'll have my u there, and this u is measured in meters per second. So you must note that. The other thing, you people know a graph paper. The vertical axis is the y, then the horizontal axis is the x. So we also have some distance. This one can be distance, but I can call it length. Are you seeing this one? Are you seeing this one also? You look here. So I want you to note that this ball is already somewhere here, but it's going to move up to such a point, isn't it? In case it comes and falls. Are you seeing that? What does that mean? That means that this ball has been both displaced. So that one shows horizontal displacement. So I can say that my ball has been displaced horizontally, because you can see this is where it was, but look at where it was. So it has been displaced through some distance, but it is horizontal. Then if you have a keen eyesight as well, you can see that this is where the ball was, but it's now here. So it has also been what? Displaced vertically. So both things are happening to the ball. Displaced vertically. And you all know it has been displaced vertically. It's like we have displaced it through the what? The y-axis. Then displacing it horizontally, it's like we have displaced it through the what? The x-axis. Yes. So I can just put your things in red so that you don't forget. Displaced vertically, I can say something has been displaced through the y-axis. Then also here, I can say that something has been displaced through the x-axis. Through the x-axis. That is the x. Then y-axis. That's why we have it as y. So when I put these letters, I don't want you to be confused. And hope you understand. So when I go back to this diagram of ours, you will allow me come here and put what? Letter y. So come here and put letter y. Then also come here and put letter x. Please accept. Things are not easy. Accept. I want us to put one letter by one letter so that derivation makes sense. So we talked over this push. It is something you're not supposed to forget. The push that gives us that u. Now, those are two things that are so far enough and important. I told you the horizontal motion, and I also told you about the vertical motion. But you need to know that vertical motion is a bit sensitive. It's a bit sensitive, and I'm going to tell you how and why. My question is, I want you people to be real. I want you people to be real. Let us consider horizontal motion, this one. Let me put it here, horizontal motion. I want you people to tell me, what is remember this is projectile motion, which is supposed to be under the influence of gravity. I told you whatever concept that disturbs people in this topic is simply because they forget that projectile motion has the influence of gravity within. So my question is, under this horizontal motion, who can tell me what is the acceleration there and why? Is it positive g? Is it negative g under this horizontal motion? Is it positive g, negative g, or something else? And what is that something else if it is none of the two? I want you to think well, don't panic, because whatever we are going to put next is what determines whether you're going to just cram projectile motion or you're going to understand it. Yes, that's what I'm interested in. That's what I'm interested in. Is it G? Is it negative G? Or it is something else that we don't know? You see, people, what really makes mechanics hard is that people overthink. But let me tell you, people, gravity does not act in the horizontal plane. Gravity only and only acts in the vertical plane. So G is positive when we are talking of vertically downwards. G is negative when we are talking of vertically upwards. The moment motion is horizontal, we assume that there is no gravity. So it is a zero. I want you to understand that. When they say vertically upwards, I'm just saying this and I'm not going to write. Vertically upwards, it is against gravity, so G is negative. Vertically downwards, it is under gravity, so G is positive. In the horizontal plane, gravity cannot act, so A is a zero. So I'm going to come here and say, in the horizontal motion, my A is 0 meters per what? Per square second. I don't know if that is clear, but I'm assuming it is. That is it. Okay, now there are certain initials they are going to be using in this topic, but just make sure you understand what Y means, you understand what X means. I told you X means simply horizontally or in the X-axis. Y simply means vertically or in the Y-axis. As simple as that. So my question is, if X means horizontally, you listen people, if X means horizontally, is this U the same as U subscript X meters per second? Is it the same or not the same? Remember, that is the initial velocity the body is given as it is pushed horizontally. So my question is U the same as U subscript X? is U the same as U subscript X? Because how you denote your work in mechanics also matters. Blessed daughter is back. Blessed daughter had said she's lost, so let me hope she's back. So when they say U subscript X, they're trying to mean U in the horizontal plane, and it is right. Our initial velocity was for horizontal motion or in the horizontal plane. I'm just still talking about the denotions. I've also explained this, I've now explained this. I want you to follow critically. Critically. Now, what if I want to go to now vertical motion? Let's now talk about vertical motion. Vertical motion. You people, let me ask you a simple question that is hard. What is my vertical motion initially? What is my vertical motion initially? Hey, what is my vertical motion initially? Oh, even if I don't ask it that way, let me be more specific before you answer. What is my vertical velocity initially? I want you to understand that this ux means initial velocity, but horizontally. Now, for me, I'm asking initial velocity, but vertically. That's what I'm asking. What do you think that value is? What do you think that value is? You just think about it. You are giving this body the horizontal push, but later on, gravity eventually wins us and it puts the body down. But I'm talking of initially, what is the vertical velocity? Initially, but not even sure by saying, oh, someone is telling me V, even when I've said initial. Yes, as a BCM student, you should cry. Things are not easy, but you should learn. Mechanics is not easy. It has never been easy. You can get a concept well and forget it in the next minute. But it's about befriending what actually the thing says. People, it is clear. Initially, what we have is horizontal motion. Vertical motion comes later. Trust me. So when they talk about initial velocity, when they talk about initial velocity that is vertical, it is not there. It is zero. And some of you have tried it. So concerning initial velocity, that is in the vertical plane. It is not there. Because initially, all you can see throughout the beginning, we first have horizontal motion before the body decides to fall. That means we don't have any force, we don't have any kind of velocity that is vertical at the beginning. Otherwise, the body would just fall immediately. But initially, vertical velocity that could immediately pull the body down or take it down is not there. Understand where I'm putting the zeros, understand where I'm putting finals, the y and x. I'm later going to use them as a substitute. So you follow. Now we are remaining with only and only one thing. The hardest things to understand, it's only this. When you understand this, you're good to go. When you understand that, you're good to go. Now my question is, what of the G? What of the G? What can you say about it? What about the G? Is it a positive or a negative? I'm talking of vertical motion. We are now talking of vertical motion. Even put the arrow here. So for vertical motion like that, what can you say about the gi? What can you say about the gi for vertical motion? Will our gi be a positive? Will it be a negative? That one is obvious. That one is obvious. It is vertical motion, the body is going down. Our gi can be considered to be positive. But I'm going to teach a certain technique in mechanics because you can find books that consider negatives. But I'll teach you how they interpret it, but that's when we begin calculations. I remember seeing some calculations in the very book we are going to use that were a bit contradicting, but in line with the right explanation. So because vertical motion, understand that initially the body is just moving horizontally and there is no vertical stuff. So it is zero as far as vertical velocity, that is initial, is concerned. Then the gi, because we are moving down, it will be a positive within gravity, under gravity. Now, there is something I need you to understand. That as I was explaining to you, I told you that finally or eventually, the gravity comes and pulls our body down. So we believe that it will pull it. Of course, what is pulling it is vertical. I want you to follow here. Of course, what is pulling it is vertical. You get? And it is the final velocity. Initially, we didn't have, and it is vertical. So how do we read this curved part? We say that finally or eventually, the gravity pulls down our body. That's why we use V to mean final. And then we attach Y to show that it is vertical, not horizontal. I don't know if people are getting that arrow. I don't know if people are getting that arrow. Then, this is mechanics. After us having let me show people something here. Let me show people something here. I could put it here that initially, for you to get the vertical velocity, we said there is nothing, and that was our 0 for vertical. Now I'm talking of finally, when the body finally decides to fall. I'm like, there is that vertical force that is pulling it down. Now my question is, do I really have this horizontal component? Now this is where things become worse. Do I really have that horizontal component? Who can tell me? Do I really have it? Let me see if people learned. Let me see if people learned parallel forces. You people, this is mechanics. Every time you have a vertical component, look for the horizontal component. So don't see as us making the diagram very dirty. No, we are respecting mechanics. Have the horizontal component, have the vertical component. Initially, we talked of the U and the UX, which we say the U or the UX is that initial velocity you give to the body as you give it its very fast horizontal push. Since initially everything is horizontal, sorry, you asking for the vertical velocity, it's not fair. That's why we are like, the vertical velocity initially is a 0 because we purely have horizontal motion. But we say that finally, eventually, gravity wins the body and it pulls it down. You get the point? So that means we may have a final velocity that is vertical. Why vertical? Even gravity acts vertically downwards. So that velocity is there. So it is a vertical component. So my question is, do we really have the horizontal component? If we have it, what is it? The vertical component, I want you to listen. The vertical component, without us considering things of parallel forces, assuming I had closed one eye, this one is supposed to be Vx. And I've told you how Vx is read as. It is read as the final velocity but in the horizontal plane. How is it read as? Vertical velocity but in the horizontal plane. Sorry, I mean final. V means final. Then U means initial. So when I say Vx, I mean final velocity in the horizontal plane or along the x-axis. I beg your pardon. U means initial, V means final, X horizontal plane, Y vertical plane. Vy, final velocity in the vertical plane, Vx, final velocity in the horizontal plane. But the problem is, are we really sure? Do you know what this Vx is? That's what I was asking actually. What is that Vx? What is that Vx? Just from the diagram we have, the hardest part in projectile motion is this diagram. Knowing whatever they put there and you appreciating how things are going to be used in the different calculations. When you get that, things are going to be very fine. Let me remove these sticks because they may confuse you. There are too many. Let me first leave it at that. Yes, let me first leave it like that. Let me see what people are saying in the chat. I'm seeing a lot of messages. It's you. It's UX. It's the very you, the initial. Yes, people are having some good ideas, which are not bad. Which are not bad. So you people, this VX you're seeing, if you just consider that direction you're seeing, you've not heard of parallel forces. They are parallel, so they are equal in magnitude. But that was for forces. So use the same concept with velocity. You can see the UX or the U is moving towards the right from the left. And you can see that we need the same. So in simple terms, the first one was U, even that one is U. Even if you do this, it will be U. Throughout, it will be U, it will be U. Even if you do what? It will be U, it will be U, it will be U. Provided you stay within the horizontal plane. So even if they ask for vertical, are you seeing this? When you go down, it will still be Vy. When you do this, 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 Vy. You understand? That's why even if we are to sketch, all of us will sketch this thing at different points of our diagram. And we shall still be calling it Vy. So that means, so have those simple principles. They are the ones that make things hard. You having this Vx, but you cannot tell that this one is also Vx. Simply because these two are parallel, and it is clear with our naked eyes. When you're having Vy here, but you cannot tell that this one is Vy, even when the line is shorter. You see those basic things. So you need to know them. But we always borrow ideas from forces, and we try to copy, even when the quantity changes and it's now velocity, but we can apply everything. So, what did we say? That yes, this one is supposed to be Vx. Why did I say Vx? That even when I'm in forces, I always say Fx. I call this one Fy. Then here in the middle is the resultant. So I say resultant force. It's the same thing that I had my Vy. So I needed the horizontal component. And just like Fx, I called it V what? Vx. Like that. So I'm now having the two components of final velocity. Now what if they need the resultant? So I just want to tell you that this one is the same as the ux. And it is very clear that the ux is the u. Just the u. Putting x to just make it very okay. Showing the plane. Now when they ask for the resultant velocity, you all know this one should be a right angle. You should show it. Then the resultant velocity will come from there like that. And then we always show it with double arrows, resultant velocity. And how are we going to write it? Resultant velocity is written as RV. Like that. Or some people write it as V R. And you can say I'm just copying things of resultant force. Resultant force. So I'm also saying resultant velocity. You see that? Now my question is, where are you going to put the angle? Because the angle also matters. So does the angle go here in green, alpha? We always use alpha for the angle, or what we call the direction. Or I'm supposed to use this one in blue. Which one is the right angle? Is it alpha in green or alpha in blue? Let me see if people understand the definition of the direction of any magnitude. Yes, we covered forces and we completed. So if you have issues with resolving and anything related to what I'm saying, you're supposed to first go and visit that lesson and see how composition is done and see how resolution is done. You see people saying alpha in blue. There are even people saying in blue. That means you have issues. That means you have issues and you're supposed to improve. If I told you angles are always with the horizontal, those are the angles preferred. Those are the angles preferred with the horizontal. So our horizontal here is Vx. So if the horizontal here is Vx, that means the best angle is this one, alpha. That means the best angle is that one, alpha. Alpha. And that is the diagram. There is nothing else. You're only supposed to understand things in horizontal motion and things in vertical motion. The only things you need to understand in vertical motion are two, and let me tick them in green. You're supposed to understand why acceleration is a zero. You're supposed to understand why the initial velocity is ux, and that it is given by the horizontal push. So I want us to go one by one. Are those two for the horizontal motion okay? The acceleration being a zero and the u being ux. Why use ux? U for initial, x showing us that we are in the horizontal plane. Why is acceleration zero? Because gravity does not act in the horizontal plane. It is always in the vertical plane. So are those two okay? I want five people per question I ask. Are those two okay? Because I'm going to begin substituting. And when we derive the formula together, I'll just use them without minding about your emotions. So are those two values okay for horizontal motion? Another question, I'm going to vertical motion. Let me tick them in purple. The two things you're supposed to know in vertical motion, there are only two. You're supposed to understand why initially vertical velocity is a zero and why we are choosing gear as a positive. Why we are choosing gear as a positive is because in vertical motion, down, we are moving down, and that is under gravity. So we use it as a what? A positive. Why initially vertical velocity is a zero? Because initially we purely have horizontal motion. So when you talk of vertical velocity, we don't even understand. It's not there. The diagram is clear that initially, you just look at where I've pressed, you look at where I have put the UI. UI means U for initial velocity, Y for vertical component. So you just look at it. Where it is purely horizontal motion. So when you ask for something vertical, it's not existing, it's a zero. And those are the two things. Are they okay? Those two things for horizontal motion, the zero and the positive G. Then we go to the last one, which is the hardest. Should we now go to the last one, which is the hardest? More two people. More two people. One more person, they are done. Okay, now the last part, which is very hard. which is very hard. So I can remove these ticks because I'm assuming they are now okay. Now, these last two parts, they are asking, okay, I said that eventually, finally, the body is pulled down by the force of gravity and it's taken to the ground. So that velocity with which it falls, you know it is supposed to be vertical because it is falling down. And it is a final velocity because we are past the initial. We are now concluding with the motion. The body is reaching the ground. So the velocities we are looking at or using must be purely vertical or must be purely final, sorry, because we are concluding with everything. So that's why the vertical force that is pulling our body down is capital V, because we are concluding with the motion. We are almost reaching the ground, as you can see. It's supposed to be final. Why? Why is it Y? Because it is vertical. So we use Vy. But as I said, in mechanics, every time you have the vertical component, ask yourself, where is my horizontal component? Why? They may ask you for the resultant. And you cannot get the resultant unless you have the horizontal component, unless you have the vertical component. If those words of resolving, magnitude, resultant disturb you, I recommend you first go and watch the lesson we recorded on forces. Yes, and then maybe some of the words may become familiar. So after us having the Vy as the vertical component, we asked ourselves, which one is the horizontal component? Then we first drew it. Then we are like, just like in forces, if the vertical is Fy, then the horizontal is Fx. So we had Fy, so we just put Fx. So we applied the same thing in the V's. You get the point? We had Vy. So the horizontal component is automatically Vx. But using that rule of parallel forces and parallel quantities, they are always equal. That's why even parallel lines have the same gradient. So you realize that Vx, I've told you everything, that if it is Vx like that, anything that is like this, like this, like this, like this, you see it finally blends with the U. That's why for us we are just saying that it is U. The Vx, the horizontal component Vx, we are just saying it is U. Or someone can even say Ux. That is according to the diagram. But I'm going to even show it to you. I'm going to show it to you from the first equation of motion so that you choose. You either use the diagram and say Vx is the same as Ux, or you use the first equation of motion and find out. So after us having the vertical and horizontal components, we asked ourselves, which one is now the resultant? What if they ask the resultant? So you get the vertical and horizontal and handle them the way you know. You get it? You handle them the way you know. Then if they ask for direction, you get the alpha. If they ask for magnitude, you only get magnitude. If they ask for resultant velocity, you should know it's a vector quantity, so you get them both direction and the magnitude. And that is the diagram. There is nothing else. Whatever we are supposed to use is now here. The other thing is that, are you good students enough that you can get the expression of resultant velocity, and can you get that of the direction alpha? And those are things I taught in forces. But before I assume that people know these things, does everyone know that resultant velocity shall be the root of Vx squared plus Vy squared? Do people know this as equation 1? Do they know it? I really want to know. Do people know that? And then the other thing I want to ask, do people know this equation 2? The one of alpha? That alpha will be tan inverse of Vy over Vx. Do people know this one as well? Do people know that one as well? Because in forces, instead of V, we had F. Yes, instead of V, we had F. So you people tell me, Tell me, tell me, tell me. Which one is the problem? Equation 1, equation 2, or both? Are both a problem, or only one is a problem? Or both are okay? Or one is okay and the other is not? Because I need to know before we handle anything else. Okay, the good thing you people have said those things are familiar. I've not seen anyone complain. Okay, I've not seen anyone complain. You people, we are done. You're going to see that all the numbers that are going to be covered, they have actually been talked about. But I was very clear, I don't want to see anyone complaining. I told you that by 1 we shall have slept. So we have over 20 minutes. So I calculated my time well. I believe you don't pressurize me. If you believe that we are wasting your time, you please log off and leave us in good faith. So those two equations, they are just the same. They are just the same as those of forces. Nothing much changes. Now, I want to begin with the horizontal motion. So horizontal motion, there are things you're supposed to take note of. We said that since it is purely horizontal, when you ask for the acceleration, that one will just be 0 because motion is under the influence of gravity. So it is a 0, nothing else. Then the other thing you need to understand that your u, which is initial, is just ux, like that. You get the point? Now, if at all you come up and use the very first equation of motion, because we use it so much here. We use the first one, we can use the second one, but basically we concentrate on the first and second. So the other thing I want to tell you as you're learning this topic is that we consider the first and second equations. Consider the first and second equations of motion. I want us to first go through these hard things. Then we go to the logbook. and I show you something that can help you. Okay, so when I come here and say using the first equation, which is V equaling to U, remember you're talking of horizontal motion. So you need to know which equation exactly is going to help you. Yes. So first equation, it is U plus AT, like that. I don't need to bring in things of gravity. So I don't need to put here letter G, because I'm dealing with horizontal motion and gravity doesn't act in the horizontal plane. So what are the things I'm seeing here? I'm supposed to substitute. So in the horizontal plane, my V is Vx, my U is Ux, my A is a 0, and I always take a certain time to move that motion. So I think you see how time is cancelling. So my V is this. So are you seeing what I told you? So I'm talking to that person who got confused by the horizontal component in our diagram. Do you remember when we reached Vx and most of you got confused and you couldn't tell that y is equal to ux when I talked about the things of parallel quantities? If that was hard, make sure you understand this. So in simple terms, for horizontal motion, the vertical, the final, remember V is for final. I don't know why. My mind always takes me to vertical when I see V. So I beg your pardon always. So the final velocity is equal to the initial one, provided we are maintaining our x-plane or the horizontal plane. So you learn that. But we are getting it from the what? From the first equation of motion. So this is very important. Equation 1. The initial is the final, provided we are dealing with horizontal motion. Okay, then let's look at the second equation of motion. So I'll say, what of the second? How does it go? It is S equaling to UT plus a half AT. Don't put your things of G. Things of G are going to come in vertical velocity. So what do you recall? They are the same things we are substituting for. The U, we know it. So S, who recalls that in horizontal motion, S, or the displacement, is X. Do you remember it on our diagram? That's what we said. That for horizontal, it's there. I told you recall each and every letter that we put there. So for horizontal motion, you can see the displacement is X. You even have here a sketch I put for you. That displaced horizontally through the x-axis, that's why we call it x. Displaced vertically through the y-axis, that's why we call it y. So the displacement through the horizontal plane is x. Our u is what? Ux, then t, you get? Then plus a half, what is the a? The a is a 0, then the t squared, the time taken. So you can see the whole of this is dying. So we are remaining with x alone as the initial velocity in that plane, then t. But I want to teach you something funny in mechanics. If you people recall, we say that since initially it is horizontal motion dominating, the vertical initial velocity does not exist. That's why you're seeing it as a 0. So it's like you're having only one format. You're having only one format of initial velocity. So you saying ux and uy may not be important because uy is a 0. Yeah, that's why you'll find so many books ignore the ux and just call it u. So they just be like vx is u. Because they know even if you call it ux and uy is a 0 for reasons I explained. So no need. You'll also find the same books having it like x equaling to ut, like this. No need of calling it ux. After all, uy is a 0. For reasons you know. So those are two equations already. Don't forget them. We are going to use them so much. Equation 1 and equation 2. X equal to ut and Vx being the same as u for horizontal motion. Now what if we go back to our vertical plane or for vertical motion? I just want to remind you, but all these ones are not necessary for you to pass a calculation in math. But I remember telling you that I'm training you to be the best students of mechanics. So I'm supposed to go an extra mile and tell you the irrelevant, but relevant. So vertically, I remember telling you that our gi, we are moving down. We are moving down. It's better we give it what? A positive like this. But I want to tell you something. Other books can say that this gi is a negative, and I'm going to tell you why. Just don't confuse these mechanics. Remember, for you, remember we are projecting this body from a certain point above the ground. We are getting it from here. So most people in mechanics, not all of them, but some people always say that since we are starting our projection from a distance, this one will always be a negative. And I think you've heard that before. I don't know if people are hearing it for the first time, but I'm talking to those people who usually do research. If for you don't do research, don't mind about other books as of now. They shouldn't stress you. They shouldn't stress you. They shouldn't stress you. So because the projection is coming from a point above the ground, they can say, this distance is supposed to be a negative. That's what they usually say. And trust me, we always get the same answers. Even you as try to use the first principles and say vertical motion, we are falling down. So let our gi be a positive. That is very okay. That is very okay. And I'm going to show you proof or something that is going to give us strength so that other books don't literally confuse you too much. So when you see a negative, just understand it's because of the distance we have below the point of projection. So because this distance is below, some people always want to treat it as a negative, and they are right. They are right. But even you who has used first principles, as we are going to do, you're safe. So in vertical motion, I told you that this one, the gi is the positive, and the final velocity v, because it is vertical, it is vy. And those are the only two things I told you must know. Nothing else. Don't add on. And you told me they are fine. That's what you told me. So when I go to the very first equation of motion, because it helps me relate this gi, it helps me relate it to the v. So I can use it and see whether there is any expression we may come up with. You get the point? So I also come and say that from the first, remember we are deriving, and in math, you're not supposed to bother yourself with deriving. But you force yourself and learn. At least learn the equations by heart, wait for calculations. We substitute and go away. Trust me, after this, you can do numbers on your own. So the first equation is u equaling to this. Okay, you can first give it a benefit of doubt and call it acceleration A. Then you come and start filling stuff. And be like, this is the Vy. You get the point? But remember, we are talking of strictly and strictly vertical motion. Then this one, you call it Uy plus acceleration. You very well know it is a g and the time taken like that. But I don't know if people recall that initially we didn't have any component of vertical velocity. I don't know if people recall that, but you told me it was okay. So I think you see that things we need time. You need to go back and repeat them. You need to go back and repeat them on your own. So this one was a 0. So since that was a 0, that means it's going to be discarded. And you're only going to remain with the velocity being only and only gt. And that is the third formula. This is the third formula. You see that? The other one was a 0. So after that, I can now also come and use the second and say that the second equation of motion, remember we are talking of now vertical part. So when I come to the second, it is S equaling to U T. You can first give it a benefit of doubt, a T squared like that. Then you start and be like displacement, but in the vertical plane, it is Y. I told you that displacement through the y-axis or vertical, it is y. Then we are talking of vertical. This one is the uy, isn't it? But the uy is a 0. So we shall have our 0, we shall have our t, then we shall have our positive, we shall have our g, we shall have our t squared, like that. Then the other thing I told you, that since in vertical motion you are falling and the distance you're covering is below the point of projection, they may say that distance is a negative and also call our g a negative. But you can see negative and negative, we shall still go back to the positive. So even if you don't mind about that. So with mechanics, people may decide directions and be like, if you're falling, the distance you're covering is a negative. So even force yogi to be a negative. But if they say upward, since it is against gravity, let's consider negative, you always get the same answer. You people who know motion of connected particles, as you're getting the values of acceleration, you know. Whether you put arrows up, whether you put arrows down for acceleration, they don't mind. You first get the answer, then you conclude. And that's what happens in mechanics. So never get confused when you see you using G, another person negative G, especially for such cases. Not on all cases, of course. It's only a few. But we shall always see those things as we continue practicing and practicing. You shouldn't be worried, you shouldn't be confused. So, to conclude, or as we conclude, this one will be y equaling to strictly a half g t squared, like that. And then this is equation 4. Trust me, you don't need any other equation. You don't need any other equation. So all I want is this. You just tell me that, are you seeing that page? Are you seeing that page? From where I've exposed it to the end, that is the only information you need to calculate. If anything there is confusing you, you will never pass case 1. Maybe you wait for case 2. And case 1 is the hardest. Case 1 is the hardest. Case 1 is the hardest. That's why I didn't want to mix it with the other 2 cases. So I don't know. Equation 1, 2, 3, and for which equation is hard? Please, Loic Grace, leave our screen. Why are you disorganized? You remove your red line. I want people to see this work clearly. So people tell me, we have our diagram, we have our equations, the 4 equations, but we also have the other first 2. The ones of resultant velocity, then the alpha, which is the direction, then these other ones. Right now, things may look too many. Maybe you're like, have not understood. But it is very okay and understandable because the denotations are many. Ux, Uy. We have alpha, we have Vx, we have Vy, we have tan, we have Vr, we have S. We have X, we have Y. We have A, we have T. We have G. All those are different letters. Again, U can be UX. Again, UY is a 0. Again, UX is there. Again, VY has the horizontal component. Again, alpha is the direction. It is understandable. You can get confused. But you need to sit down, make notes, and understand. All I can say, I've tried my level best. So, which part is confusing? Because when I open the calculations we are going to do, we just look at the answers. Only. This is mathematics. They just want you to substitute, answer, substitute, answer, substitute, answer. Substitute and answer, substitute and answer. So any question, anywhere, because the questions we are going to do are just 3. They are just 3 or 4. Then you do the 5th and we shall be done. And then we shall come for other cases next time. So I think you can see how I'm good at managing time. I knew by this time I would be done with the derivations. Yes. So, any questions? Are the 6 equations okay? We go to the question. You people, I'm asking. Okay, I'm having some people supporting me. Yes, and that is good. Now, let us go to the calculations. Hey, let's go to the calculations. Doctor, you're not talking about acceleration. Why? I've talked about it. Acceleration Y is the G. Because acceleration Y means acceleration in the vertical plane. And we said for vertical motion, because we are moving down, the G should be now a positive. Are you understanding? Hey, the G should be a positive because we are going down. But as I told you, in other books, don't be surprised when it is a negative. And I told you what makes it a negative. What makes it a negative is this. These people reason and say, if the projection is beginning from here, you get, and this is the ground. So these people be like, we are covering distance that is below the level of projection. So this distance must be a negative S. And to make matters worse, so even when these people are falling, even when it is under gravity, they just forcibly make it a negative. But we always get the same answer. There is no way the answer can be different. Never. Never. It will never happen. It will never happen. So I don't want people to confuse you. That's why I give you reasons for everything, so that you don't reach somewhere and just say, Paul Tutor told us this, and you stop there. Who is he? So defend yourself and be like, it is this distance is below the level of what? Projection. So when you make it negative, that means you've considered it is below the level of projection. So you're like, the distance, I'm going to consider it as a negative. So do the same for the acceleration, because you've decided that your downward is a negative. That's what you've decided. But another student can say, for according to me, downward, for me, I'm going to take it as positive. That is no problem. It is no problem. No one should ever lie to you. Because even when we are doing connected particles, I told you that it depends. You can decide to either, if you're having a body here and a body here, it's you to decide. You can make this body face down or up. They can make it face down or up. With mechanics, it is no problem. Just become a best friend to mechanics. So don't be confused when you find such things. In the end, this negative will even cancel and you remain with your positives. It is very okay. So when you find anything contradicting with what you know in mechanics, don't cry, don't do anything. First do what you know. See if the same answer is coming through. That is all. Especially for these parts I've talked about, not for all parts. And make sure whatever you're doing, you're having a reason for it. And whatever we have derived, I've given you a reason. There is nothing I've told you to learn by heart. So I expect that I'm releasing or producing competent students of mechanics. Let's go. So they are saying this is chapter 10, but these are notes of the old curriculum, but it's the same content. So it's the motion of a body after being given an initial velocity. I told you that under the influence of gravity. Very good point. Angle of projection, horizontal. Very important. About initial velocity, I've oversaid it. I told you these ones are going to be important for us in the next cases. Yeah, but the trajectory is the path described or followed by a projectile. That one we said it. These people also derived their formulae. I don't know if it will be convincing enough to you guys, but we have also derived ours and they are the same, I guess. So you look at this first number. You look at this first number. I gave you time to look at the formulae and you told me everything was okay. So they are saying a ball rolls off the edge of the table top 1 meter high. Are you seeing? So when they say 1 meter high, you know that this is my value of y. Get the point? Because they are talking of height, and height is the vertical displacement, and vertical displacement is the y. They are giving us horizontal velocity of 1. I heard this one is u. No need of even saying ux. Even if you say ux, ui is 0. Like ui doesn't exist, so you're wasting time to say ux. And what are they asking? They are asking the time taken or the time it takes to hit the floor. You like it or no time taken to hit the floor, you're supposed to use y. So do you see that you're supposed to go back to your formula and look at that? You look at that formula of y. Let me expose all of them. You look at equation 4 of y, the last one. Can it give us the answer? I want to just show you that these things are easy if you know the formula. If you try to do mechanics from first principles, that will need a lot of practice, but you need to be knowing these formulae. Trust me. Trust me, you need to be knowing them. So people tell me, can the fourth equation give us the answer? Or it can't? Can it give us the answer or it can't? What are people saying? Yes, it can. Okay, that is good because you're going to just substitute. You have the value of y, you put g, and then get the value of t. As simple as that. Nothing much. So you look here, what these people did. I think people, you see the fourth equation here? It is y equal to a half gt. But in case someone is like, hey, but doctor, what if it has been an exam right now and they're asking me to do the same thing? What would I really do? What would I, or what will I really do? Or what would I have done if it had been an exam? So I want you to check. You get your logbooks. I want only one person to get a logbook. Only one person is enough. Let me give you a technique for the lazy students. Let me give you a technique. You get your logbooks. You get your logbooks and look for mechanics. You get your logbooks and look for mechanics. I don't know if you people have how come I cannot see what I want? Which kind of logbook is this? If we don't see the formula, then I think you people will have to struggle locally. Anyone who has seen the formula that I want, you tell us the page. think. Should I assume they are in the current logbook and not this one? But why would it be like that? They have to be here. Okay, people, under the section of mechanics in the logbook, which formulae are there? Anyone with the logbook? The current one, third edition. The edition I have is the old one, but I thought those formulae are there. The one saying page 65, can you unmute and read for me? Can you raise up your hand and you read for me what is there? The one who is saying 65. Because I know you're meaning the page. But for me, I'm not seeing them. Yes, thank you so much. Francis, unmute. What is there on that page?
I'm saying equations of a linear motion, equations of trajectory. I'm saying horizontal motion, which is x equals to u
That's
cos.
where I want. That's where I want. A moment. What it is logbook, which page?
65, number 78.
It is page 65, number what?
78.
By 78. And does it have something like horizontal and vertical? Are they both there?
Yes.
You read for me horizontal. On horizontal, what is there in horizontal?
X equals
X
u
equals
cos alpha.
U
U cos
cos
alpha. It's
U
in
cos
brackets.
alpha T.
U cos alpha t. Yeah.
Oh, these ones are going to disturb us. Do you see anything there like U is equal to, sorry, X is equal to UT? Is it there?
X equals to ut.
Or Y is equal to a half GT squared? Are they there or they are not?
But there is sine and cos.
I know, but that is something else. Remember, we talked of projection at an angle. So where we have an angle, that's where we shall see those ones. But meanwhile, anyway, it's okay. So they are like this, but with angles, eh?
They aren't
Anyway,
there,
it's
sir.
okay. It's okay. It's okay. I get you. That means you don't have a solution as someone who has not understood how they are derived. So you'll have to struggle a bit locally. So you need to know the four. So what do I advise? You understand whatever you're supposed to understand. There is no shortcut, and sorry about that. So don't need the logbooks. So you're supposed to summarize what the question has provided. It has given you y as 1. So question 1, the y is 1 and the SI units are there, the meters. You're having u as also 1 meters per second, and they're asking you for the time it takes to hit the floor. They're asking you for the time t. Simple as that. So you just need to look for which equation is going to help me. Which equation really has the time I'm looking for. So if you're this person who has not captured the formula, you're gone. Because just look at the 4. The third one is just dt and vy, and you don't have vy. The second is x ut and you don't have x. The other ones of resultant velocity are other things. So you only have the fourth. So you're supposed to use the fourth, like you have no option. So you're supposed to come and write the fourth. Even if you just write it, it is very fine. A half dt. You're looking for time. Put here 1, then say a half dt, This is 9.8, then t squared, like that. Then get the value of time. And then it's a done deal. I told you that those people who may decide to put here negative because they say this 1 meter is below, when they put here negative, they're supposed to put here what? Negative. You get the point? When they put here negative, even here it's what? Negative. And so the negative cancels and they come up with this step and get the same answer. Just always make sure in mathematics that you substitute well. When you substitute well, you can just show a few evidences of working your computations and then you write your final answer. Like that. Then Roman 2, they asked for the horizontal distance covered. Horizontal distance, according to our sketch, horizontal distance is x. And horizontal distance is what? UT. The U is there in the question. We've summarized it. It's there on top. It's a 1. Then the T, you've just obtained it here. So you do the same. You come and substitute for U, which is a 1. You put the value of time and then finally get your X. It is horizontal distance. So it's supposed to be in what? In meters. And that was the unit in the question. You get? Then they asked, lastly, the velocity when it hits the flow. So they're asking you for the final velocity. I don't know whether people are getting this. So here the time, if you use your calculator, well, someone tell me the time here. We do this whole number. So that the rest we just do chap, 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 chap. Someone get me the time there. So these things just follow up and let your mind tell you that maybe when you read through, you will understand. But we are supposed to complete. You are candidates. We shall study. I don't leave class if at all I feel like the learning outcomes I stated can be achieved. So what is my value of time? Those with calculators for that part. Which value of t are you getting? But please hurry, 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 hurry. Which value of t are you getting? Which value of t are you getting? You people, okay, let me get it on my own, but that is bad. People get tired too fast. 2 divided by 9.8, then the root of the answer. I'm getting 0.4. 517551. This is math 2. So the minimum is, first of all, is 5 seconds. So they just want to see how you substitute and how you write your answer, period. So for you to come and get horizontal distance, which I called x, which I called what? X. Should substitute the u initial value which is in the question, and then also this. My T1, this 5. So I end up getting the same answer, 0.45175, and it is in meters. This is mathematics, not physics. So they just want to see how have you what? Substituted, how have you written your answer, and you get marks. Now Roman 3 is what is having issues. I want you to be extra careful and listen. This is very important. They're asking you for the velocity as it hits the floor. The question is here. Velocity as it hits the floor. So let me take you back. So if you people recall very well, what did we say? We said that it is coming. Remember, it's having this, then it's also falling like this. So we said as it is coming to hit the floor, this is the floor. We said it's going to have this, which will be the final velocity, the vertical one. Then it also have this component. So as it's coming to hit the floor, it's not having only one component. The components are two. It's also having this Vx. Remember, this one is u, no need of saying ux for reasons you know, but the Vx is also the same as what? A u, that one I warned you already. And you all know the u, according to the question, it is a what? A 1. You get the point? Then the question is, what is this Vy? You need it. So in case you don't know the Vy, that's where the equation is going to help you from. I know none of you can recall the one of Vy, but it is here equation 3. You see? Vy is just get t, and we have the value of t. So we can get it. You get? Yes. If you feel like you've forgotten, which is very normal, you go and check. Don't hesitate. So Vy we can get by saying that Vy is g what? G t. So I come and say Vy is g. What is the g? 9.8. What is the time? 0.4175, if I'm not mistaken. That is the time. Then you be like, if I use the calculator, what do I come up with? Let me use my calculator. For you guys, I don't trust you. So time was 9.8. So I'm getting 4.4. I don't know if I'm right. 4.4. I'm getting 4.4. I'm getting 27. Then 19. And it will be meters per second. So you first secure these marks for the V, this and this mark. You secure it. But as I told you, there are people who will say that no, this velocity is looking down. This velocity is looking down. If it is looking down, then it's supposed to be a negative. But even if they put a negative, you shall get the same answer. They are not looking for the vertical component. They're not looking, for us, we are considering downward as positive. It is very okay in mechanics. So when someone teaches you and they tell you, you put a negative, don't argue. Just accept the fact that they are like, this one is facing down. Let's consider negative. So their downward is the negative. But for us, we are like respecting gravity and saying, let us take the gravity side. It's in line with gravity, so let everything be positive. That one is also okay. So when you find negatives, I don't want you to be confused at all. Okay, so we have our V. So we have the V and we also have the Vx here. But remember, they want the velocity. They want only one. So you're supposed to resolve those components into one. Yes, and that's where resultant does what? Comes in. Hey. But what did the question ask? It asked for velocity. Velocity is a vector quantity. You must provide both magnitude and direction. And what is direction? Direction is that alpha. Oh, that I explained. So first come and hope them get the resultant. And you people told me, okay, with the formula of what? Of resultant. You're the ones who told me. So you just come and say, resultant velocity is the root of Vx squared. What is my Vx? My Vx is a 1. 1 squared plus Vy squared. What is your V? 4.42719 squared. So I think you people can see that even if you had a negative here, you would come here and square it. And whether you're squaring a negative, whether you're squaring a positive, you get the answer as a positive. So it will cause no harm at all. So this is substitution. You get a mark for this. Then you conclude with the what? With the resultant velocity. That's what the question wants. That's what the question wants. So, what is the answer you people are getting? So the answer squared, how am I writing this? People, what is the answer? 4 point, I think I'm tired. 4.42719 4.42719 squared plus 2 root of the answer. If are you getting 4.6 something? Is it what you're getting? I'm getting 4.64758 meters per second. That's what I'm getting. Is it what people are also getting? Or people are getting a different answer? Seems I've made a mistake. Which one is the mistake? 4.42719 squared plus 2, then square root. Why is mine different? Yes, Raj. Yes, Raj, where is the mistake?
So you made an error with the value of Vy.
And you people are quiet. That is bad.
Because
Four
it has to
five.
be 4.42715.
Oh, 715, yeah?
Yes.
Oh. So when I put here 5, does the answer resemble that of yours? You people, which answer? Where are you getting that answer from? And no one is supporting their answer. Do you have a different Y? Or I used the wrong T? Did I use the wrong T? 45175. And you people just square 2 divided by 9.8. Then the root of the answer. That was correct. Then this one times 9.8. That's what we get. Then we square this. Oh, I get. I get you people. Actually, this person is making me change my value for no good reason. This value 9 is okay. The 9 is okay. The 9 is okay. And this answer is 4 point. I've gotten the error. I beg your pardon. 4.3, then 87, then 2 meters per second. Yes. And then you get your mark. Like that. But remember, that is now magnitude. We need the direction. You get? You need the direction. So the direction, you just come and say, my direction is tan inverse of Vy, which is this 4.42719 over Vx, which is a 1. Then you just press your answer in the calculator at once. You people, it is okay to first show the formulae. Yes, I know there are friends of mine who always want to first show the formula. It is okay. It is okay. It is okay. From here, you can always first say, but I know resultant velocity is the root of the Vx when Vx is squared, and then the Vy when it's squared. It is okay. Then from here, you go here. Then I know you always want to first show the formula. Maybe it's what helps you attempt very fast. So you can first show the formula. No problem. Vy over Vx. Then you substitute. Hope people have the answer ready. So from there you come, say, so it will be tan inverse. My value is 4.42719 for Vy over 1. Is it 1? The Vx, yes, it's equal to initial. And this is what they want to see in mathematics. The substitution, provided it's correct. Then you come and conclude. Which answer do you people have? The angles are recorded to 2D P's in math. Angles are recorded to 2D P's in mathematics. So tan inverse of 4.42719, we are having 77, 2D P's, 77.27 degrees. Yeah. Angles are supposed to be in 2D P's. 2D P's, it is a must for angles. It's a must for angles in degrees. If they are in radians, you go back to the norm. But if it is degrees, 2D P's. So you also get a mark for this. But remember, you're supposed to conclude, yeah? Because that angle is with the horizontal. So how do you conclude? You talk about the velocity and tell us that the velocity we have obtained, or you can even call it the resultant, to be more specific. You tell us that it is having a magnitude. You mention it, then you also tell us the direction. So you may be like, how do you mention the direction? You tell us that it is the angle alpha with the horizontal. Like that, with the horizontal. I think you can see, things are not hard. People just look at that solution from the beginning. It just needs you to have understood whatever we derived. Now you come and apply them. I've tried my level best to do for you the first one and how to identify the formula to use. So other examples in the book, we're going to just be going through them chap. Especially understand that part of resultant velocity. How you get the direction, how you get the magnitude. The others, you just identify what you have and what they want and choose the formula to use. Nothing much. Okay. So, before we go through the solution in the book, I want you people to tell me, is that okay? Is the solution okay from the beginning to the end? Because that is a pure question. It can come as a full scenario. And the same question can be converted into an item. And all scores are there, 12. It is fit for 12 scores. So is the number okay? Have you been interpreting it together and can you do it later on your own? Only 3 people, only 4 people, at least 5. Okay, that is good. Now you look at what was done here. You see what I was telling you? Because they are saying it below point of projection, that's why these people are using -1, which is okay. So they use negative here and negative here, but later things cancelled. Even here, you can see that their Vy, because Vy is looking down, they said let's give it a negative. But later on, they had to square and the negative disappears. So you see how they got the resultant and then the direction. So this is how the conclusion is done, as I've said, that the velocity is this is the magnitude you mention, and you also talk about the direction. How do you talk about it? You say at an angle alpha to the horizontal. Like that, nothing much. So you just need to reason, make a summary of what has been provided, look through the formulae and see what to use. So these are the ones I'm not going to do a lot because they have it all. They said a ball is thrown forward horizontally from the top at this velocity. So you've been provided with the u. So you have u as 10. And the height of the cliff above the ground is 45. So you have the value of y as 40 what? As 45. Yes, you have the value of y as 45. They are asking you for the time to reach the ground. Provided you have y, you have that equation relating y and t, it is here. You just use it. So because this y is below the point of projection, they may decide to use it as a negative. But when you consider it as a negative, you also take this one to be what? A negative. Very simple. The whole thing is for the negative to cancel out so that you don't get a time that is a negative. So this has been handled. Then they're asking for the distance from the cliff to where the ball hits the ground. This is horizontal. You get? Like this is the point of projection or the cliff, and this is where the ball hits. And I told you that's what they call horizontal displacement, which is x. So how do you get x? You get x by saying u t, of which u has been provided in the question. It is 10. And then t, you have just obtained it in Roman 1, the t. So don't you see, you just get the two, multiply them and get the answer in meters. Why meters? This one is in meters per second, the time is in seconds. Very obvious. Is that really hard? Then here they're asking for the what? For the direction. And you know what to do for direction. They want alpha. And for you to get alpha, you need vy and v what? Vx. But all of us know that Vx is always equal to the initial, according to the diagram and also from the first equation. So it is 10. Then Vy, we just obtain it using this formula Git, which we derived, and it was equation 3. Why are they for them putting a negative? Because it is facing down. So they chose their downward to be a negative, but you can take yours to be a positive. You see this? They get the Vy now. So when you have Vy and Vx, you just get the direction. You didn't even have to get the magnitude. They only wanted the direction. So you could just say the speed is at that angle to the horizontal. So the magnitude was just to accompany it. So just know the first example we did is the most complex because it almost talks about everything. You understand? This was the first equation. This was the second. This was the third. And this one, I think, was the fourth. These numbers we are doing, they are taking whatever we derived is being used. You just look here. You know, for me, I'm a man of evidence. I always want you to leave the place when you're happy. You look here. And I want to just show you that whatever we have derived has been used. You look here. This question is the same as the one we have just done. The one we exposed. They are the same questions. So I just want to show you something so that you leave this place happy and contented. The things are actually doable. Why is this thing misbehaving? So look here. Are you seeing the first equation we had? The one I called equation 1. Let's even first look at the other first two, the one of resultant and alpha. Those two, they are here. You look here. So the resultant is here, then alpha is here. So those ones have been used. The formulas are 6. The ones we derived, you come here. Are you seeing the second one we did? The one of Vx being equal to u, it is here. Vx being equal to u, that is the one we called the first one. It was used. Look here again. Look at that second one, which says x is equal to ut. You look here, it's here. X is equal to ut, so it was also used, and we also used it in the previous one. Look at the third, the one which says Vy is equal to Gt. It is here. Vy is equal to Gt. It has been used. You understand? Look here, the last one, y is equal to a half Gt. It is here, the very first one. The first one they used here. I think you see that. Just one number and whatever we derived has been used. And this example is just the same as this one. So it's like we've done it all. You can see this one is the fourth. This one is the, I think the third. This one is the first. This one is the second. Then these two of alpha and resultant. Trust me, you're done with horizontal stuff. You're done. You look at number 3. You may think I'm kidding. Let's read through it. They are telling you the object is projected horizontally at a speed of 20, not so? So speed of 20, that means that is u. U is what? 20. Then from a height 100, this one is your y. And they are saying it's what? 100. You people, you have u and y as 100. And they are asking for the time of flight. Time of flight, this one is the same as the time taken to hit the ground. For horizontal, I don't want you to confuse the time of flight we did before and this one. Do you people realize that if this is the point, if this is your ground and the ball is coming from here and you want it to move like this, do you realize that the time of flight is the time it needs to hit the ground? So this one you don't need to say, even if you say capital T, you treat it as small t. There is nothing like multiplying by 2 or what, no? Just understand the real thing happening, don't cram. With the horizontal projection, it is clear. The time of flight from this point to this point is the same as the time taken by the ball or the body to hit the floor or the ground or whatever. So there is nothing like capital T, small t times 2. Those ones don't exist. And I think you can see you have been given u as 20 and then y as 100, and they want time. So you just come and use this formula. Why they are having negative on both sides, I explained and I'm tired. So you now have the t. Now look here, part B, they're asking for horizontal range. Horizontal range is horizontal distance x, which is the same as ut. The u has provided in the question as 20. Then the time you've obtained it here in part A. So just come and use here what? X equal to ut. Then this velocity on reaching the ground, don't you see that is the same question they are repeating over and over? They don't even have what to set. So questions always rotate there. Just because you need to know that the velocity they are asking for, as the body is falling, the velocity has the vertical and horizontal what? Component. So you're supposed to do what? To resolve. Not forgetting the position of the alpha. And this is mathematics. The sketch is important. They give it a mark. In physics, they may not mind about the sketch. Even in math, there is when the sketch is not important. But for mechanics, especially when the diagram involves resolving, it may be important for you to draw the diagram correctly. That's why I had to draw my diagram there as we are solving this. See my diagram there as I was doing Roman 3. You just try to use the ruler very well and show the crucial points. You always get a bonus mark for that. For numbers where you cannot proceed with the diagram, even when your calculation is correct without the diagram, you lose marks. I told you that in forces. So you please revisit and listen to the rules very well. So I think you can see the same formula have come back. Vx being u, v being gt, why they have negative here, the resultant coming back, the alpha being tan inverse of vy over vx, these things. Remember in forces we used to say f this over this, tan inverse, even in resultant instead of f vr we had fr. So it's like we have just removed f and put v. So if you understood forces, then this one has been clear. I don't really think Someone has found a hard time with this. So there are those of you who have not watched vectors, and here they used vectors. So I'm going to urge you, this one is understandable because they're asking speed and direction, which you already know. I will ask people to first visit vectors. I'm not going to introduce those things of I, J, and K right now. That is very bad. But trust me, when you first visit vectors, yes, I will ask you to first visit vectors of pure math. Because when you do applied math, you also do pure math. They are there on the drive. And then come back to understand for. Otherwise, you can even understand it without. You can understand it if you have knowledge already. And then come back to understand number 4. But I realized many of you are weak students. How can you doze off? How can you decide to leave a lesson that is going up to 2? Because this holiday we are going to have lessons that gap to 3, that gap to 4, because we are supposed to complete work. How will you manage if some of you run away? Imagine math students are many, but I don't think now we even make 20. People disappeared. People are not strong students. I don't know. For us, we used to be very strong students, but students of nowadays, I don't know why, they don't stress themselves. Passing A level is not very easy. The day I will share my results, all of you will be shocked and you will lose, you will even be demotivated, because some of us repeated work in senior 4 VAC and repeated the same work for 2 years. Some of us entered into senior 5 when we can do a standard paper of pure math and chemistry paper 1 strictly. To understand this, number 4. Then number 5, it has a very good diagram. I think this diagram, it's a combination, but very understandable. So number 5 is your research. So you're going to combine research, and the other one that needs you to first combine vectors. You can see the next thing here is exercise. So we are done. So first take a screenshot of both number 4 and the 5. 5, which requires you to first visit vectors. You understand I, J, and K. Then the research number that has a combined diagram. Otherwise, the basics you've gotten from this class are very enough for you to proceed with some good work in the future, as far as projectile motion is concerned. Hope the screenshot has been taken. Now we start taking the exercise. I don't know. Are those words, are they clear at that point? Are they clear or they are not? It's okay. Let's take that. That is clear. Take that. Take that. Then I'll begin with 4 and 13. Take that. The assignment. Input the assignment. I don't know, but today I've left a lot of assignments. I don't know if people do that work. But if you don't do the work, you'll never benefit. Trust me. Assignment. Okay. Take that. Now begin with 8 and 16. Take that. Even the answers are there. So you can see there are so many numbers having vectorial approaches. That means you gotta visit vectors and get back to understand things well. Take that. You just enjoy these good things. 250 high from the bottom, initial speed, velocity. We have tried our level best to derive that stuff. It's very sensitive. Very, 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 very sensitive. Okay. Yeah. This is our next stop, yeah? Objects projected upwards from the ground at an angle to the horizontal. That is our next stop. I told you already. Yeah. So let me first save this document. So let's check the learning targets. Why I always want to finish my learning targets, because for me I feel happy when they are done. So we tried our level best and defined. I always enjoy ticking them. Resolving the terms we resolved. Then cases, I told you my learning target is actually dealing with horizontal projection from a height or point above the ground. Then these ones, they were for next time, case 2 and case 3 and others. Then you have the research, you have the assignment. That means you only have case 1, case 2, then standard equations, and I think we shall call it a topic. So I want people to go back this time round when they know something in mechanics, so that when you reach more complex topics, you can do something. This very holiday may be in January or towards the end of the year. We may also do something about friction, maybe. Yeah. Otherwise, thanks for attending. Those who have stayed on up to this late, thanks for being strong students. May God see you through in all your academic endeavors. And I also thank God for enabling me to reach this time, even when I've not slept for even when I've not had serious rest for some days, but I've been strong enough to be here. So we don't take that for granted. We should keep praising God and thanking Him for the good heart. Otherwise, bye. I don't know if you have concerns. You're supposed to do those questions. The answers are there. Discuss. Discussion group. You know what to do. You know what we always do for assignments. Whether you do individually, whether you do in a group, whatever, I don't mind. Just make sure you do assignments. Make notes from my video lessons. Do assignments. If you can, attend live classes. But if you prefer recorded work, it is also very okay. Otherwise, have a good night, people. Bye-bye.